in this video, we're going to look at the complement of an event. So the complement of an event is that the event does not occur. For example, if we say that there's a 60% chance of rain today, that means that there's a 40% chance that it will not rain. Those two events, rain and no rain, are considered complements. The formal way of denoting a complement, so if we have event A, then the complement of event A is written like this. And the probability of complements should add up to 1. So if we want to find the probability of the complement of A, we would subtract the probability of A from 1. This is a lot easier than I think that just made it sound. So let's think about this. If event A is rolling a 6, what is the complement of event A? So if event A is rolling a 6, then the complement of A would be not rolling a 6. Or rolling a 1 through 5, right? Anything that's not 6. So if the probability of rolling a 6 is 1 out of 6, then the probability of not rolling 6 would be 1 minus that 1/6, or 5/6. Just remember that complements, the probability of complements should add up to 1. So this and this should add to 1. So we looked at this problem earlier. We had 10,000 families, and it says a pollster samples a single family from the population. In a previous example, we looked for the probability that a family rents. And we found that the probability that the family rents is 0.3769. What if we asked, what is the probability that the sampled family owns? Well, we could add up the probability that a family owns a house with the probability that a family owns a condo, just like we did for the renting. But we also know that renting would be the complement of owning. So since I've already figured out the probability for renting, I could say that the probability of owning is going to be 1 minus the probability of renting. And so I would do 1 minus the 0.3769 to get 0.6231. Here's another example. So it says Mars Incorporated manufactures peanut butter M&Ms. They report that they make 10% each of brown and red candies, 20% each of yellow, blue, and orange candies. The rest of the candies are green. If you pick a peanut butter M&M at random, what is the probability that it is green? Well, the probability that it's green is going to be 1 minus the probability that it's not green. And the probability that it's not green are all of the other probabilities, right? The probability that's any of the other colors. So that would be the probability that it is brown, red, oops, I didn't mean to have a comma there. Yellow, blue, or orange. And if I add these up, I have 1 minus 0.8, which means that 20% of the candies are green. If we want to find the probability that a randomly chosen peanut butter M&M is red, yellow, or blue. So I have an or here, but these are mutually exclusive events because it's not possible for M&Ms to have more than one color. So if I want to find the probability that they are red or yellow or blue, we would add the probabilities together. So I'll add the probability of red to the probability of yellow to the probability of blue. And we don't have to subtract off any intersections since these are mutually exclusive events. So we'll have the probability that it's red is 10%, yellow is 20%, and blue is 20%. So this will total 0.50. What's the probability that the randomly chosen peanut butter M&M is not orange? Well, the probability that it's not orange is going to be 1 minus the probability that it is orange. So this will be 1 minus the probability that it's orange. It says 20% orange, so it's 0.20, giving me 0.8. So we have another Venn diagram here. It says in the US, approximately 42.5% of households have a dog for a pet, 28.6% have a cat for a pet, and 7.2% have both. What is the probability that a randomly selected household will have a dog or a cat for a pet? So I'm trying to kind of bring in some review problems here. We'll look at an or question, and then the next question is a complement question. So let's set up the diagram. And we've got, so we have the dog circle should total 0.425. The cat circle should total 0.286. And the intersection between the two is 0.072, which means that the percent or the probability of families that only have a dog will be the 0.425 minus 0.072. And this is 0.353. So that is the probability that a household only has a dog. The probability that a household only has a cat, we'll take that 0.286 and subtract off the 0.072, and we will have 0.214. So when we want to find the probability that a household has a dog or a cat, I'm going to use the formula. And so we'll want to find the probability that the household has a dog plus the probability that the household has a cat minus the probability that they have a dog or a cat. Because I'm using the formula, I'm not looking at the Venn diagram, I'm looking at the values in the example, in the problem. And so I'll have 0.425 plus 0.286 minus 0.072. And we will get, there it is, 0.639. And again, we could use the diagram, and if we add 0.353 plus 0.072 plus 0.214, we'll also get 0.639. The next question, what is the probability that a randomly selected household will have neither a dog or a cat for a pet? So I commented that this is going to be a complement problem. And that's because when you're looking at a Venn diagram, or anytime you have two scenarios, two events like this, there's really only 4 possible outcomes for these events. Either we have only a dog, only a cat, both a dog or a cat, both a dog and a cat, or neither, meaning all of the ones that don't occur within this circle. Since the or problem are these 3 events added together, then the probability that a randomly selected household will have neither a dog or a cat will be the complement of this. So the probability they will have neither a dog or a cat is going to be 1 minus this 0.639. And it will be 0.361.